right, well, thank you all so much for joining us for tonight's very special program. Tonight, best-selling author Avi Loeb will discuss his recent critically acclaimed book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth. And let me tell you a little bit about Avi. He is the Frank B. Baer Jr. Professor of Science at Harvard University. He's the chair of Harvard's Department of Astronomy. He's the founding director of Harvard's Black Hole Initiative. And he's also the director of the Institute for Theory and Computation, ITC, within the Harvard-Smithsonian Center for Astrophysics. So let there be no doubt who is the smartest person on this call tonight. Avi is the author of 4 books and over 700 scientific papers. He's an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. And in 2012, Time magazine selected Avi as one of the 25 most influential people in space. So all nearly 200 of us, let's give a big virtual round of applause to Dr. Avi for joining us tonight. And Dr. Avi, you can take it away. Thanks so much.
Thank you so much for having me. Let me share my screen. So although my focus would be on the book Extraterrestrial, I would like to share with you some recent developments. In fact, today I had a few television interviews, and last week, since many of us are in Massachusetts, let me show you a video that was featured on NBC Boston. So I will just put it full screen. It will just be a few minutes, and then we'll move on with my slides.
My name is Avi Loeb, professor of science at Harvard University. In the coming months, I'm going to lead an expedition to Papua New Guinea to scoop the ocean floor and search for fragments from the first interstellar meteor.
Although Avi is in search of what he believes may be alien technology, proof of extraterrestrial existence has never been what's driven his life's work until now.
I'm hopeful we will find something. The question is, what is it? An unusual rock, a natural object, or artificial?
Despite being the longest serving chair of Harvard University's Department of Astronomy, it wasn't until recently that he started to investigate the possibility that there is life beyond our solar system.
I found a catalog that the government compiled of meteors that were detected by government sensors that are missile warning system. I asked my student to check if any of the meteors, the fastest moving meteors, could have arrived to Earth from outside the solar system.
There was one in particular that sparked the interest of Loeb and his students, Amir Siraj.
We decided to write a paper about this meteor, which was discovered on January 8th, 2014. Light from the explosion was seen by government sensors.
Despite the government releasing limited data, he had discovered something groundbreaking. His paper laid out what he believed to be true. But 3 years after writing his findings, a major development confirmed what he knew all along.
After a few years, the release of a letter from the US Space Command in the Department of Defense stating explicitly that this meteor at the 99.999% confidence level came from outside the solar system.
Based on the speed of the meteor and how much of the object burned upon entry, Avi determined that it must be made of a material that is tougher than iron.
And so this one was an outlier in terms of its composition. It was also an outlier in terms of its speed outside the solar system. It moved at least twice as fast as stars move relative to the sun in the vicinity of the sun.
Armed with new evidence validating his findings, Avi decided to take action and make moves to recover the object, his next hurdle. Funding through private donations, he has secured a portion of the money to take the trip.
Let's continue to look for objects like it. It was obvious to us that we need to go there and collect the fragments, because to do the same thing for an object in space would cost more than $1 billion. For a cost that is 1,000 times lower, we can go to the ocean floor and collect material from an interstellar object.
Now, Avi has the task of finding an object that most likely fractured on impact, leaving fragments possibly the size of pennies lost at the bottom of the ocean. It's a challenge that might seem insurmountable in the vast existence of the Pacific Ocean, but Avi is confident they will recover what they are in search of.
It's a fishing expedition, literally speaking. And what we can do is basically take the trajectory of this meteor and extrapolate it all the way to the ocean surface. Now, of course, when the explosion took place, there were fragments generated and they were scattered over a region. One imagines that the tiny pellets would be carried farther away from the point of impact, whereas the heavier fragments will sink down closer to the impact. Finding a big chunk can inform us much more about the structure of the original object. We're planning to board the ship and build a sled and a magnet attached to it that will scoop the ocean floor, and we will go back and forth like mowing the lawns across the region 10 kilometers in size and collect with the magnet all the fragments that are attracted to it and then brush them off and study their composition in the laboratory. This will be the first time that humans put their hands on the material that makes an object that came from another star.
With more advanced technology in our skies than in any other point in history, new findings are becoming far more frequent and impossible to ignore. Thanks to a government report that was released last year, the possibility of extraterrestrial life and the pursuit of proof of its existence is finally losing its stigma.
The stigma has been reduced. It would be the most important scientific discovery that humanity ever made, because if you think about it, it will change our perspective about our place in the universe.
With science in his corner, this professor is not intimidated by critics.
It's not a philosophical question whether we live in an environment where objects are floating around that are representing extraterrestrial technologies. We just need to use our telescopes and find out. In fact, we are not even the first to say that. Galileo Galilei said that 4 centuries ago, and he was put in house arrest. Today, he would have been canceled on social media. Once I realized that we found an object from a technological origin that was produced elsewhere, I would not seek approval from anyone else. I don't need likes on Twitter. I just want to know what it is.
Okay, so now let's get to the actual presentation. This was just a teaser. Since it came out in Boston, I wanted to show it. Okay, so as I mentioned, you can see the cover of my book in the middle here. And if I had to summarize it by one sentence, I would say, if you are not ready to find exceptional things, you will never discover them. What you see on the right is the cover of a textbook that I also published last year called Life in the Cosmos. And I should also mention that 2 days ago, I delivered my next book to the publisher. So it should come out in June 2023. That's a follow-up to Extraterrestrial. And what you see on the left here is a photograph of a picture that was hung on the walls of the Berlin Brandenburg Academy of Science and Humanities, where a German photographer, Herlinde Quilbel, came to my office and asked me to write on the palm of my hand the question that I regard as most fundamental in science. And I wrote, "Are we alone?" What you see here is a group photo that was taken just a few weeks ago at a conference, the first conference of the Galileo project that I lead, that was established a year ago. So we celebrated the first year accomplishments. I'll say more about the project, but there are about 100 people involved in it. And this is a video produced after this conference.
It's such a great privilege and pleasure to see 70 members of the Galileo project team coming together, celebrating the past year accomplishments of the project. And we are just at the beginning, because in the coming year, we hope to collect data and find out what it shows. We make no assumptions, we are completely agnostic, but it seems like the government is telling us that there are some exciting objects out there that we need to figure out what they are. And that's our hope. For now, we assembled the relevant instruments, we are testing them, and we will soon deploy them and start collecting data. Because the sky is not classified, and we very much hope to discover what the nature of objects that the government is talking about and that astronomers are talking about that look like outliers are. Are they technological in origin from another planet, or are they natural phenomena? And the Galileo project aims to find out along 3 tracks. One is looking at unidentified aerospace phenomena in the sky and imaging them in the infrared, optical, radio, and audio bands. The second is rendezvousing with interstellar objects in space and taking a close look at them. It will cost about $1 billion to meet an interstellar object. There is a much cheaper way of doing that, and that is to find an interstellar meteor. We know of one that landed near Papua New Guinea in 2014, and we plan to search for the fragments from this meteor by scooping the ocean floor. And that is the 3rd branch of the Galileo project. So we have very exciting times ahead, and we look forward to what we will find.
So yeah, I'm Ezra. Had a great time on this project so far. It's been great working with the team that we've had. You know, come to the rooftop, hitting your thumb with a hammer, sweating all day, lifting heavy objects, and just working with several of the teammates that have been here for up on the rooftop with me for a few weeks or a couple months now. It's been an honor to work with them and meet these people. I'm excited for what the future holds. This is just a preview of what's to come. Getting a first look at our instrumentation, getting our hands on it. It's working, and we're getting data. And now is what I consider really the start of things, where we get to put in some really nice sensors and expand our reach and set up at different locations. And that's where the real exciting parts come together, and really looking forward to this next year.
Okay, so let me start by highlighting the fact that we will be following the scientific method along all these tracks that were just mentioned. And what did the scientific method tell us? What's the biggest message we got from the universe over the past century or so? We now know that about half of all the sun-like stars host an Earth-sized planet in their habitable zone. So what we find in our backyard is not privileged. It's not unique. There are more habitable Earths in the observable volume of the universe than there are grains of sand on all beaches on Earth. And that should bring us a sense of modesty. I call it cosmic modesty. We should be filled with humility because we are not really central players. And when I look at pictures of an emperor or a king that were very proud of themselves after conquering a small piece of land here on Earth, it reminds me of an ant hugging a single grain of sand on the landscape of a huge beach. That's not very impressive. But I can understand where it's coming from because I watched my daughters when they were young. They stayed at home and they thought that they are at the center of the world. They thought that they are the most intelligent anywhere. But then that illusion was crushed on the first day in the kindergarten. They met a smarter kid. And so our civilization will mature by finding others. And my point is that Albert Einstein was not necessarily the smartest scientist who ever lived since the Big Bang, 13.8 billion years ago. There were most likely many smarter scientists on exoplanets around other stars 1 billion years ago. And the civilization that benefited from the wisdom of these scientists could have launched probes that by now would have reached us, even if they were propelled by chemical rockets. It takes about 500 million years to traverse the entire Milky Way galaxy, and then another half perhaps to if these probes replicate themselves. But overall, 1 billion years is a long time for such probes to fill up the Milky Way galaxy, all the habitable zones, including our solar system. So I call these AI astronauts, artificial intelligence systems, because it takes tens of thousands of years for light to cross the Milky Way galaxy. So there is no way for a probe to wait for guidance from the senders across interstellar distances. The probe has to be autonomous. So if it's functional, it has to have its own machine learning, learn from experience, and its brain should have artificial intelligence. And so the question is, do we have AI astronauts in our vicinity? And the only way to find out, it's not a philosophical question, the only way to find out is by looking through our telescopes. And we should not repeat the mistake that philosophers made about 4 centuries ago. They knew that the Earth is at the center of the universe. And when Galileo argued that no, the Earth moves around the sun, they refused to look through his telescope and they put him in house arrest. So if we look around us, what do we find? The first report on an interstellar object came in 2017. It was an object discovered by a telescope in Hawaii. It was given the name Oumuamua, which means a scout in the Hawaiian language, and didn't look like any of the rocks that are familiar to us from the solar system. And then it turns out that this was not the first object that humans detected. 4 years earlier, there was a meteor, an object that collided with the Earth that came from interstellar space. We discovered it with my student, as you heard already. It created a fireball as a result of the friction with the air in the lower Earth atmosphere, about 100 miles off the coast of Papua New Guinea. And the government issued a letter that you can see on the left from the Department of Defense, confirming indeed the conclusion that we reached with my student, Amir Siraj, at the 99.999% confidence. And the government also released the light curve from the fireball that included 3 flares. And since it exploded in the low atmosphere, we concluded that it had to be resilient to very extreme stress. It was moving at 45 kilometers per second, very high speed. And that meant that the object had to be very tough, tougher than all 273 other objects in the meteor catalog, and actually tougher than iron. And so it was an outlier, and it was also moving faster than 95% of all the stars in the vicinity of the sun. So the question is, what is it? Is it a rock of some unusual nature? Or maybe it's a spacecraft. So we plan an expedition to scoop the ocean floor. I received $500,000 in donations. We still need to raise another $1 million before we go out. But basically, we'll use a boat with a sled and a magnet and scoop the ocean floor. And we have an expedition team that includes people who are very experienced at such expeditions. And what you heard is the seismometer signal that was recorded on Manus Island near Papua New Guinea from the impact of the first interstellar meteor. So you may say this is the sound of the universe knocking on our door. Enrico Fermi asked, where is everybody? Well, he was sitting in the living room waiting for someone to knock on the door. Here is the knock. Why don't we check? And the other thing is he never looked through the windows. He just asked the question. But in order to find your neighbors, you really need to look through the window. You better use a telescope. So we are planning to scoop the ocean floor, and hopefully that will be done within the fall of this year. Then Oumuamua was much bigger. This meteor was roughly the size of a watermelon. And we could see it because it burned up in the Earth's atmosphere. But Oumuamua did not collide with the Earth. It was just seen at a distance from the reflection of sunlight off it. And it was roughly the size of a football field. And it came from a very special frame of reference called the local standard of rest. That's the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. So it's sort of like the local parking lot, and only 1 in 500 stars is so much at rest as Oumuamua was in that frame, which is quite unusual. Then it was kicked by the sun as a result of the gravitational force that the sun exerted on its motion. And as it was coming close to the sun, it reflected sunlight, and it was tumbling every 8 hours. But the amount of sunlight it reflected changed by a factor of 10, which meant that it has a very extreme shape because the area projected on the sky changed by a factor of 10 as the object was tumbling. And the best fit to the variation of the light was that of a flat object, pancake-like. Again, very unusual. And there was no cometary tail whatsoever. The Spitzer Space Telescope looked in the direction of Oumuamua, and what you see on the top right is an image from that telescope. Basically, it's just noise. There was no detection of any carbon-based molecules. So it was definitely not a comet of the type that we are used to. But nevertheless, surprisingly, there was a force acting on it, pushing it away from the sun. And it couldn't be the rocket effect because there was no evaporation that we could see. So the only force that I could think of that would decline inversely with distance squared is that it's being pushed by reflecting sunlight. And for that, the object had to be very thin, sort of like a sail, a light sail. And nature doesn't make such objects. So we wrote a scientific paper saying that. And there were a number of anomalies that I describe in my book regarding Oumuamua. But you may ask, okay, so what did the mainstream astronomers suggest to resolve these anomalies? And there were 3 proposals made by mainstream astronomers. One is that this is a cloud of dust particles, 100 times less dense than air. So just imagine steam coming off a pot, a boiling pot. This object had to be 100 times more rarefied than steam, 100 times less dense. And that is in order for it to be pushed by reflecting sunlight. So it had to be very low density. The problem with that idea is that when such an object would get close to the sun, it would be heated to hundreds of degrees and it wouldn't survive. It wouldn't have the material strength to keep itself together. So then there was a suggestion, maybe it's a chunk of frozen hydrogen, because hydrogen is transparent, so it actually evaporates, but we can't see the cometary tail because it's pure hydrogen. The problem with that idea is that hydrogen evaporates very quickly. So this object would not survive the journey through interstellar space. So then a third team came up with a solution and they said, okay, well, it's a nitrogen iceberg, a chunk of frozen nitrogen chipped off the surface of a planet like Pluto around another star. The problem with this idea is that there is not enough solid nitrogen to explain a large enough population of Oumuamua-like objects so that we will see one of them. The fundamental question is whether Oumuamua was natural or artificial in origin. And the way I think of this is when you go on the beach, most often you see natural objects, you see rocks or seashells, and that resembles the asteroids and comets that we see in the solar system. But every now and then you might see a plastic bottle. So perhaps Oumuamua was a plastic bottle, indicating that there is a civilization out there. Turns out there was another object discovered in September 2020 by the same telescope, which exhibited the same qualities as Oumuamua. It was pushed away from the sun by reflecting sunlight and had no cometary tail visible to us. But then the astronomers who discovered this one, which is called 2020 SO, they realized after a few weeks that if you go back in time, this object actually came from Earth. It was a rocket booster launched by NASA in 1966. And it was hollow and the walls were thin so that it was pushed by reflecting sunlight. No cometary tail because this shell of metal does not evaporate. So we know that this object 2020 SO is artificial because we produced it. The question is, who produced Oumuamua? And of course, if you imagine a cave dweller finding a cell phone, the cave dweller will argue the cell phone is a rock of a type that I've never seen before. Just like Oumuamua is a nitrogen iceberg, a hydrogen iceberg, a dust bunny. These are things we've never seen before. But there is a simple way to settle the issue. If this cave dweller will press a button, he would realize that that can record his voice. And another button can record his image. So in fact, this cell phone is not a rock. So all we need is more evidence. Now I should mention my book Extraterrestrial, which discussed Oumuamua, inspired a vineyard in Santa Cruz to have a brand of wine called La Cigar Volant, where they mentioned explicitly the fact that, you know, it's supposed to represent Oumuamua. And we used this brand of red wine at the conference that we had earlier this month.
Daily double. You are well in the lead at 4,400. How much would you like to wager?
Let's do 2,000, please.
Here's your clue. I look at the world and I notice it's turning, thanks to this man who studied at the University of Krakow in the 1490s.
Who is Brahe?
No, correct response. Who is Nicholas Copernicus? You lose a little bit. Pick again, Robin.
Scientist for 600.
We think of this Russian who became a professor of general chemistry in 1867 periodically. Robin.
Who is Mendeleev?
Yes.
Scientist for 800.
Avi Loeb thinks a space object seen in 2017 and artistically depicted here comes from this 16-letter type of being, the title of his book. Kevin.
What is extraterrestrial?
Correct.
Scientist for
Daily.
And I should say there was also a sermon delivered about a year ago by a rabbi in a congregation in Ann Arbor, inspired by Extraterrestrial. And he wrote to me. And I found that quite remarkable that there is something in common between trying to figure out the unknown and spirituality. So this scientific quest for extraterrestrials resonates with religious people. So altogether, there is a new frontier in astronomy that just started over the past decade. There are 3 interstellar objects that were discovered so far. So this is really a very special decade. And Enrico Fermi asked this question 70 years ago, where is everybody? And obviously, we need to look through the windows and use a telescope. And there is also a new era in government, and we might hear more of it in the coming weeks and months. I just had 2 interviews today about the government, talking about Congress defining a very special type of objects that they're seeing, that the government is seeing and does not understand. And if you want to see that interview, it's in Nation News, or News Nation, sorry. So there was a report delivered by the Director of National Intelligence a year ago in June 2021 to Congress, and that led to the establishment of a new office. And NASA just established a committee that will study those unidentified aerospace phenomena and recommend future funding for it. And then there is new legislation in progress right now related to all of that. So it's quite remarkable that we have all these developments roughly at the same time. And astronomical search only began recently, but just keep in mind that we could only see objects as big as a football field from the reflection of sunlight. There might be many more smaller objects and many more objects moving very fast that astronomers didn't even recognize. So the coming years will be exciting. And if you ask, what is the substitute to Drake equation? That's the equation that describes the approach that SETI took over the past 70 years, which is as soon as we developed radio communication, we said, okay, let's search for radio signals from other civilizations. That's not necessarily a good idea because the modern use of radio waves for communication is just a century old, and that's a very small fraction of the age of the Earth, and we are moving away from it. We have fiber optics, we have here on Earth, and we are using lasers for communication in space. So this technology may not be used for very long, but nevertheless, that was the focus of the SETI community. We didn't see any radio signal, but it's not necessarily the right approach because it makes much more sense to look for objects because any civilization that is worried about others finding it or worried about predators, they would not broadcast their existence. They would just send probes to inform them to get to the places they want to reach. And instead of the Drake equation, one would look for interstellar objects or interstellar archaeology. So in this case, the number of objects that we will find is just the number per unit volume that was accumulating over the age of the Milky Way galaxy times the survey volume. And in case we rely on meteors, these are objects colliding with the Earth. It also, the rate by which these objects collide with the Earth is also related to the speed by which the objects move. The higher the speed, the more objects per unit time collide with the Earth. And of course, both the number and the speed may depend on size. So small objects are more likely to be far more numerous. But these equations should also be multiplied by another factor, which I call the Ostrich Factor. That's the likelihood that we will behave like ostriches and not even look, which is what we were doing before the last decade. So if we don't look, we will not find anything. If we don't invest in this search, we won't find anything. So the likelihood of discovery depends also on us, not just on them. Right now, on the surface of Mars, there is a rover, which is pretty much a robot, looking for signs of early life on Mars. Obviously, if we find evidence for microbes on early Mars, that will not be a threat to our intelligence. But imagine this rover bumping against the wreckage of an advanced spaceship. That will be a blow to our ego. And they say a picture is worth 1,000 words. In my case, it's worth 66,000 words, the number of words in my book. I wouldn't need to write the book if we had a high-resolution image of Oumuamua. You can see such an image on the right. That's an image of the asteroid Bennu, taken by the OSIRIS-REx mission that landed on it and will bring a sample from it back to Earth. So one of the objectives of the Galileo project is to design a space mission that will rendezvous with the next Oumuamua. And we have a dating app for this date. It's called the Vera Rubin Observatory in Chile that will start operations in a year. It has a camera with 3.2 billion pixels. Just keep in mind, the cameras you have in your cell phones are millions of pixels, a factor of 1,000 less resolution of the sky. This one This camera is 3.2 billion pixels, taking a video of the sky all the time in the south, in Chile. Every 4 days, it would cover the entire sky, and we'll find more objects like Oumuamua. And just like a dating app, most of the time we will swipe to the left. And only when we decide that an object is sufficiently interesting, we'll be willing to spend $1 billion in rendezvousing with it. And of course, we have also the Webb telescope that can look at such an object from a different direction than the Earth. The terrestrial telescopes are looking at it, and from that we can figure out the three-dimensional motion very precisely. Why was Oumuamua thin and flat? Maybe it was just a letter carrying a message for our salvation. In that case, it would be tragic if we miss this love letter in our mailbox. When I go to Harvard Square, I very often see statues or monuments or paintings of former deans and presidents that wanted to preserve their physical appearance. That's not the best way to maintain a monument of yourself, because within 1 billion years, the surface of the Earth will be burned up by the evolution of the sun. And a much better approach to maintain longevity is to send an AI system to space that would carry your wishes out there. That is the best monument that one can construct. And we have an embarrassment actually on the New Horizons spacecraft. There was a small box that NASA attached to it that carried the ashes of the discoverer of Pluto, Clyde Tombaugh. Now, ashes are just burnt up DNA. They're no different than cigarette ashes. They don't carry any information. So if extraterrestrials find this box, they would say, we don't want to have anything to do with humanity. They do not seem to be rational. They must be very aggressive. They burn up the genetic information about a person that they want to commemorate. Anyway, getting to the government, the Pentagon report led to congressional hearings, and as I said, NASA announced a study, and that led to the establishment of the Galileo project about a year ago, which I already mentioned. And we plan to basically monitor the sky in the optical, infrared, audio, and radio bands. I will skip the details. These are the instruments, the suite of instruments that we put on the roof of the Harvard College Observatory. We will move them to another location and test them and make sure that everything works, and then deploy them hopefully in January 2023 to start collecting high quality data, because waiting for the government to declassify their data is like waiting for Godot. You can wait forever. So we better look at the sky, because the sky is not classified. Let me just mention one other example of substance that we don't fully understand, and that is most of the matter in the universe. In 1933, Fritz Zwicky realized that most of the matter of the universe is not the matter we find in the solar system, not the matter that we are made of. So it's now labeled dark matter. We know that it exists because it exerts gravitational forces on ordinary matter that we can see. Now, in the context of searching for equipment from other civilizations, there is this statement by Carl Sagan that is often quoted. Extraordinary claims require extraordinary evidence. And I say, actually, extraordinary evidence requires extraordinary funding. And a good example is in the context of dark matter. We built the Large Hadron Collider for a cost of $10 billion to search for dark matter in the form of the lightest supersymmetric particle. That was a very popular idea, $10 billion. We haven't found it. So if in the coming decades we spend billions of dollars on the search for technological equipment from other civilizations, and we don't find anything, then within a few decades from now, we would be at exactly the same point as the search for dark matter is right now. And that is part of the mainstream of physics. Of course, one can look for other signatures of extraterrestrial civilizations like industrial pollution in the atmospheres or city lights on the night side of a planet. And one should keep in mind that there is a tension between the technological development of a civilization that allows it to venture into space, but also allows it to destroy itself if it doesn't pay attention to the climate, for example. So the question is, which of these tendencies wins? And that will dictate how many probes were launched into space for each civilization that perished. And one solution to Fermi's paradox is indeed that most civilizations that predated us are dead by now. We can't get any radio signals from them. We can't have a phone conversation with them, just like we can't have a phone conversation with Wolfgang Amadeus Mozart. But we can find the music notes that he left behind. So we can find those technological relics produced by other civilizations. They could take two forms. One is space trash. These would be pieces of equipment like our spacecraft that age for 1 billion years. In 1 billion years, New Horizons will not be functional anymore. It will just be space trash. Perhaps this meteor that I talked about before is space trash. And then the second category is functioning devices in the form of AI astronauts. So we don't have a protocol for how to engage with a visitor in our backyard. And there are some fundamental questions. Who represents humanity? And if there is a large technological gap, then we won't be able to understand the intent of that device. But my hope is that by finding relics of more intelligent kids in our cosmic block, we would be inspired to ignore the small differences among humans and cooperate as equal members of the human species. Because the cosmic play is not about us. We know that because it started 13.8 billion years ago, and we just came at the end. Moreover, we are not at the center of the universe. So if you think about it, if you arrive to a stage and you see a play going on, and you just arrive at the end of the play, and you are not at the center of the stage, then the play is not about you. And you better seek other actors, because they may know better than you what the play is about. Thank you.
So Avi, wonderful job as expected. So folks, let me turn my camera back on here. We can take approximately 10 minutes of questions. And let me pull up the questions. I would encourage folks to leave the questions in the Q&A rather than the chat, so I can read them all in the same place. Gordon asks, how do you know that when you sweep the floor of the ocean, that this out-of-galaxy object will be attracted to the magnet?
That's an excellent question. We don't assume that. It's only if it's made of metal that can be magnetized, but we will also have behind the magnet a net that will collect debris from behind, and hopefully it will filter out the fragments irrespective of whether they're made of metal. But it's an excellent question.
Teresa asks, if you find something on the ocean floor, what would happen next? Who would own those objects? What kind of testing and research would be done? And how would all that be funded?
Right. So I was approached by people who wanted to fund the expedition as long as they can commercialize the product. And I said no, because this is a scientific investigation. In fact, if we find a big chunk of material that has some buttons on it, I would be really curious to press one of these buttons. But I also promised the curator of the Museum of Modern Art in New York City that I will bring it there for an exhibit because it's a piece of modern art, probably. At any event, the goal is to collect whatever we find and bring it back either to a university setup, like the Harvard College Observatory, or to a museum where it will be available for any person, any scientist worldwide to examine. So it will not be the property of anyone. Just like nature itself is not a property of any scientist. We just want to figure out what it is. And we will basically use a standard instrumentation to figure out the composition. For example, with a mass spectrometer, try to figure out what kind of isotopes the object is made of. And at the very least, even if the object is natural, we would be able to demonstrate that it came from outside the solar system based on its composition. The isotope ratio would be different if it came from another star. But there is also the possibility that instead of being made of the standard elements that comprise, that make, meteorites, this one will be made of some alloy that is artificial, that nature doesn't put together. And obviously that would change everything.
So Allison asks a question. We got several different variations of this question, but basically she asks, are there any other people searching for this item? Are you and your team the only one, Avi, or are there other people out there that you're maybe racing against?
Well, we discovered it. We have the coordinates, but in principle, we want to do it as soon as possible so that, nobody else will go there. So we are basically waiting for funding, and at the level of $1 million, that's what we need to get it going. And it's not a lot of money. I mean, some of the people I know tend to have a party for that cost. I've been to some parties like that, $1 million, but someone has to come forward and give us the $1 million in order for that to happen. And I hope, as soon as we get it, within 2 months, we can go there.
Let's see here. I could go in a bunch of different directions. We have some great questions. Let me ask a couple of questions from Catherine, who actually read your book. She says, how can we lay people help to encourage young scientists to maintain the childlike curiosity that you talk about and to have them follow the data instead of the trends?
That's an excellent question. And that's what worries me the most, because science is supposed to be guided by evidence, not by prejudice. And for example, in the context of the search for or trying to understand the unidentified objects the government talks about. So here you see an example where the government is puzzled by it. Director of National Intelligence, Avril Haines, I sat next to her at the Washington National Cathedral event half a year ago. And I asked her, what do you think these objects are? And she said, I don't know. And so the government is puzzled. The government is not a scientific organization. And the public is extremely excited about trying to figure out what these objects are, the unidentified objects. But the scientific community ridicules it. And you ask yourself, how is that possible? This is completely unhealthy because, very often in the past, I used to hear scientists sitting on committees that allocate funds to research. And they say, we shouldn't fund this risky project because we are using taxpayers' money, and therefore we should be conservative, not to waste taxpayers' money. But here I say, listen to the taxpayers. They want us to study this, yet there is no funding for this subject, no funding whatsoever. So how did we come to that place? Well, it's because the academic community sort of is, first of all, motivated by something different. Experts want to maintain their self-esteem, their status, by trying to explain everything that we see in terms of their past knowledge. So if they used to work on rocks in space, when Oumuamua shows up, they would say, it's a rock. Now, it doesn't look like the rocks we've seen. They say, okay, it's a rock, but it's a rock of a type we've never seen before. This way, they maintain their status. They never admit that there might be something that they missed. And it's all driven by ego. And that is very unfortunate because it basically suppresses the progress of science and innovation. The biggest problem is young people, when they watch this going on, they say, well, I should not deviate from the beaten path, because if I want to get a job, I have to please those senior people who are basically not allowing deviations from the beaten path. And I'm of the opposite opinion. I read Robert Frost, who said that taking the path not taken made all the difference for him. And for me, it allows me to find some low-hanging fruit, because nobody takes that path. So there might be some discoveries to be made. Now, how do you protect the young people? Well, one way I'm trying to do that is by advocacy. I'm trying to suggest that the current intellectual climate is unhealthy. It's unhealthy to innovation. It slows down the progress of science. We should not be motivated by experts blocking innovation. And the second thing in this context is we should listen to what the public cares about, to what the government cares about. And it's obvious that this will become mainstream activity eventually. It's just a matter of time. And I'm just trying to use common sense. Now, when I was in Israel, I served in the military at a young age. And I remember a statement being said that sometimes a soldier has to put his body on the barbed wire so that others will cross. And that's the way I feel. I mean, I was attacked personally on social media. I don't have any footprint on social media, but I feel that it's worthwhile fighting this fight, because first of all, for the health of academic discourse and the future of science, but more for the young people. So that, I mean, just to give you an example, a couple of months ago, there was a conference in Martha's Vineyard to celebrate my 60th birthday, and two junior faculty, two young people that are assistant professors, came to me and said, it's really difficult to see how people respond to new ideas, and we are considering leaving academia as a result. They told me that. And it's unfortunate that this is the situation we're at. And, I'm trying to change it for the better, but it will take time.
So, folks, as we start to wind down, I think I'm going to ask Avi one or two more questions. If you enjoyed tonight's program and want to thank Avi, feel free to do that in the chat now. And we'll start to wrap things up. I'm going to ask you one or two more questions, Avi.
Sure.
This question comes from Jeffrey. If we were to stand next to a Moa, would we see a big rock or a machine that is obviously designed and manufactured by an intelligent race of beings?
We don't know, because we didn't have an image of it. But, that's the nature of scientific inquiry. We have to get close to the next Oumuamua and take a photograph of it, or land on it, or examine a meteor that collides with the Earth. For a much lower cost, we can go to the place and figure out what it was made of, and perhaps about something about its nature. So it's all a matter of evidence. I don't want to imagine anything, because the chance of another civilization being exactly at the same technological stage as we are is really small, because we developed science and technology only over a century. That's a tiny fraction of the age of the Earth, 1 part in 100 million or so. And so they are much more likely either to be much more primitive than we are, or much more advanced than we are. And the primitive ones are difficult to get to, because you need to go to those planets, land on the surface, search through the bushes and trees for them, and then it's a huge amount of effort. However, the more advanced will reach us through these probes. So we just need to look around, and we might not be able to understand. Now, for us to design tactics and, as to how to respond, how to engage with this, would be just like intelligent ants on the sidewalk trying to decide how to engage with a biker that stops. It's not clear. I mean, if the disparity, if the gap, the technological gap is huge between us and them, it doesn't really matter what we do.
So, Avi, I think we're going to wrap it there. Do you have any last words for the audience before we wind it down?
Stay tuned. The coming years should be interesting.
Yes, I agree. I agree. So, folks, I want to thank the 12 partnering libraries. I want to thank the Corning Foundation and the Friends of the Tewksbury Library for sponsoring. I want to thank Wellesley Books for being our bookstore partner. I want to thank the 200 or so of you that tuned in tonight. And most importantly, I want to thank Avi for what was a wonderful discussion. So, Avi, thank you so, so much. Best of luck. I hope you can easily raise that additional $1 million, and I hope that your search is very fruitful. And I think you're literally changing the world. So thank you all so much, and I hope everyone enjoys the rest of their evening. Have a great night.
Thank you.
Bye-bye.